All right, so very good evening, guys. Very good evening. Time that we quickly revise NCRT what we did in last 2 days and solve the questions that this beautiful book throws in front of us. Quickly, we will take the questions that we have in this beautiful text, and therefore, what we get is we have to see, right? So, all the questions that the NCRT throws in front of us, we'll quickly scroll through the concept of each question. We will solve some of the questions also, and then we will see on where are we, because that is really important. When you come to question solving per se, the first source of your questions has to be NCRT, both solved in text and unsolved. Solved in text, unsolved in text, and then your exercise questions. In class 12, there are certain chapters where the sum of these three, solved example in text question and then exercise, adds more than 50-60 plus questions, and therefore they are really important. NCRT questions can be thrown right away in front of you straightforward, and if you have done it earlier, it really gives you an advantage. Alright, so that is where we have to plan it out. Very important. How do you take it? Alright, so let's quickly start the session on this note. We started with this solution. The first question that we have read the NCRT yesterday, so we will not take the text for now. We will take the text only if it is required to solve a question per se. Right? So quickly let us do it. The first question that we have is the solved example that talks about calculate the mole fraction of ethylene glycol in a solution containing 20% ethylene glycol by mass. Two concepts. Number one, your mole fraction. Quick, this is an important question, guys. Two concepts. Number one is the mole fraction. Number one is the mole fraction, and the other one is mass percentage. Two concepts in a single question, and therefore it becomes an important question in itself. The first question of solutions chapter becomes an important question in itself, right? 20% by mass means 20 grams means 20 grams of means 20 grams of C2H6O2 in 100 gram of solution. Sir, mass percentage is mass of a component divided by total mass of the solution. Mass of the component divided by total mass of the solution is called as mass percentage. So how do we take it? 20 grams means 20 grams means 20 grams of C2H6O2 and therefore 80 grams of water, because total 100 is the mass of solution. So what will be the mass of solvent? 80 grams, right? Solvent is equal to solution minus solute. Okay, solution minus solute. 20 grams, how it is? Now, moles of it is 20 upon mass for C2H6 is 24 plus 6 plus 32, 62. And then this 80 upon 18. We get the moles from each side. Here we get it as 0.322, 0.322. And there we get it as 4.44. So what is the mole fraction? My moles chi A will be equal to Na upon Na plus Nb. Similarly, chi B can be equal to 1 minus chi a. And there you can find the answer. Very, very important question. Very simple, I should say, but then it is important, right? Obviously, I should say it's a simple question, but it is important also. Correct, sir? Done with this first solved example. Important question, and therefore we did it. It's important. If you take it forward, example 2.2 talks about the molarity. Very, very simple, not exam important because it's really very simple per se. So how we have it is that molarity of a solution containing 5 gram NaOH. 5 gram NaOH means 5 upon what is the molarity? My molarity is number of moles upon volume of solution into 100 into 1000 if it is in ml, right? Number of moles upon volume in ml into 1000 because we have to take volume in liters, but in case it is in ml, therefore divided by 1000. So what do we get it as? Number of moles is 5 upon 40. Where come 40? Because NaOH is 23 plus 16 plus 1, which is 40. So number of moles is 5 upon 40 into volume is 450 ml. But since it's in ml, so it will be 1000. So how do we quickly do that? It's 5, 8, and then this 100 upon 45 into 8 is what we are getting right now. Then even from 5, 20, and then 9, 20 upon 72. Another you can cut it by 4, which says 5 and then 2. So it's 5 upon 18 is the exact answer that we get. 5 upon 18 is the exact answer that we have. It's 5 divided by 18, 0.278 molar. You can write it as molar, you can write it as mole per liter, or whatever you want to write it as. That is how it can be written. Right? Done. Next, when you come here, the next question comes from molality. What was the difference in molarity and molality? We have molality equals to number of moles of solute. Same thing, number of moles of solute. But then denominator should have mass of solvent. If it is in grams, then into 1000. So there in case of molarity, we know it was, in case of molarity, we know it was mass, volume of solution. However, in molality, you should remember it is mass of solvent. Right? Good one. Mass of solvent. So now it says calculate the molality of 2.5 gram of ethanoic acid in 75 gram of benzene. Very, very simple. 2.5 gram ethanoic acid, what would be the moles? 2.5 divided by weight is gonna be 12 plus 3 plus 12 plus 32 plus 1. 12 plus 3, 15, 15 plus 12, 27, 28, 28 plus 32, 60. So weight is gonna be 60. Now this is gonna be the number of moles into what happens next? Mass of solvent is in grams, which is 75. Mass is only required your molar weight or something, something, something. Moles is not required. Moles is required only for solute that we have taken it. 75, and since it's in grams, so it's gonna be into 1000. And you get the molar. It's as simple as that, sir. Some questions in NCERT are simple also, and that is why is this here. Quickly, let us do it as 25 is 3. It's 30 basically, I should say. Then 33,300, 10 upon 18 is the answer, which is double of the previous thing into 2, that is 0.556. but the unit is gonna be molal or mole per kg. There it's gonna be mole per liter. Here it is mole per kg. Very, very important. Very, very important. All right. The audio is clear for now? Okay. Hmm. Correct, correct, correct. Audio is clear. Right? Good one, sir. Now we come to the first set of in-text questions. We solve the questions right there and right then. At least till the end of this 1 hour session, we should be able to solve all the in-text and the solved examples. That is the first aim we should do while solving any question, any book. First, NCRT. Right? Now, this first question, 2.1, we already did in the yesterday session. We have done it here also. 15.2, that was already done in the yesterday's class. Then 2.2 also was done in yesterday's session, I think, because we have written it important. So 30 gram of benzene, yes, it is covered here. That is also done in the yesterday's session. Then we have 2.3, that is also done in the session yesterday. And now we have 2.4 and 2.5. 2.5 as a really, really good lengthy conversion questions which we talk about right now, and 2.4 is where the question which we will do. Calculate the mass of the urea required in making 2.5 grams 2.5 kg of 0.25 molal. Now how it goes is 0.25 is the molality, then 2.5 kg is the mass of solution, just the denominator. Then you have urea NH2CO NH2, the mass becomes 60, and then your quantity above is X normal, which is your mass of urea, which is your mass of urea, right? Mass of urea. Correct, sir? Done, sir? Very good. So what is the answer that we get quickly? It's gonna be 0.25. Let us calculate the answers also parallelly. Into 60 into 2.5. 37.5 is the answer. 37.5 grams. Right? Clear? Now you see here, the next question is a beautiful question. Very, 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 very important question, I should say. Therefore, I just want to shift some text that I've written here to somewhere away. I hope you would have copied it by now. But then in case you haven't, then okay, let me drop it here. Because the next question that is gonna come is a very pretty question, very, very important question. In your language today, it is gonna be so beautiful, so elegant, and that thing. It's very important. Mm-hmm. Okay. Right? Anybody who is attempting it, please keep on trying. Don't think it's not an attemptable question. It's very, very important, and you can attempt it also. Take 2 minutes of hint. I'll give you a hint for 2 minutes. Calculate the molality, molarity, and mole fraction. All three you have to calculate. Having Ki, if the density of 20% mass by mass aqueous solution is 1.202 gram per ml. Number one, density is equal to mass upon volume. Okay. And then the second hint is that my mass percentage is mass of a component divided by total mass of solution, obviously into 100. So when I say Ki, first of all, I should know the mass of I, which is going to be around 108, 109. Mass of iodine, 127. Quickly, take a minute and try to solve it. I'm telling you, 20% of Ki means 20 grams of Ki in 100 grams of solution. Remember, guys, 20 grams of Ki in 100 grams of solution. In short, two things to take care. One is 20 grams of Ki in 80 grams of solution, in 80 grams of solvent. That is how you calculate molality, right? That is how you calculate molality. What is that quickly now? 20 upon Ki is going to be 39 plus 127. This is your moles into your weight, which is 80. It's in grams, so into 1000. Right? Very, very important and very, very easy also. Very important, very, very easy also. Right? Sir, I want to study chemistry in depth. This is good, yeah, not a problem. Nobody stops you doing that, I think. Easy explanation. Nobody stops you dealing your subject with depth, Baba. It's most welcome. It's 20 upon 80 into 127 plus 39, 166, and then into 1000. Right? So what is the answer that you have? 20 into 1000 divided by 80 divided by 166. You have 1.506. 1.506 molar. 1.506 molar. Now with the same formula, you can calculate your mole fraction also. What is your mole fraction? Mole fraction is correct है कि नहीं? It's absolutely correct, right? So your mole fraction is Na upon Na plus Nb. Already you have taken the moles of Ki. Moles of Ki is what is 20 upon 127 plus 39, which is 166. And then the second one is moles of B, which is say 80 grams moles of water, which is 80 divided by 18. Right? Correct. Moles of Ki and then moles of H2O. Right, sir? When we have both of things, you can always calculate the mole fraction. Always means always. Mole fraction is the ratio of the moles, nothing else. My moles upon total moles is my mole fraction. Not a doubt and very important concept also. Right, sir? Agreed. Last but not the least is my volume, which says my density is equal to mass upon volume. Mass upon volume. How we go it about it is that when we say mass upon volume, what we say mass upon volume, when we say density given in the question is 1.202. 1.202. Okay, nothing else is given. 1.202 equals to given weight upon molecular weight, right? Right? 1.202 equals to given weight. How much is given? 100. Solution is always 100, right? 100, and then you get the volume. With density is mass upon volume, you calculate the volume, and just as you calculate the volume, you calculate the molarity also. Quickly, let us copy this question. This is in text question only, but this is very, very important. Very, 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 very important. Very important. Quickly pen it down because it will be very, very useful to you. Very quick. 2 minutes of time, very quick revision. Done question. Question number one done. Okay, right. So this question stands now done. Quickly, we go back to the NCRT and our first in-text worksheet gets completed. 5 questions here and 3 questions examples, 8 questions solutions done. We move forward, we have a concept which is called as Henry's Law. We called as Henry's Law. And what was Henry's Law, sir? My partial pressure is equal to Kh into chi, proportional to the mole fraction is here. So, partial pressure is proportional to the mole fraction. Constant is Henry's constant. Correct? Right? If N2 is bubbled through the water at 293 Kelvin, how many millimoles? Just an indication of writing millimoles, nothing else, like ml. When the volume is less, we use ml, and that is the intention of writing millimoles also. Hmm. Assume N2 exerts a partial pressure of 0.987 bar, given the Henry's law constant for nitrogen is 76.48 kilobar, right? The formula is very simple. P is equal to Kh into chi. Now the first thing that I get here is P is known. The total pressure, partial pressure that I have is 0.987 is equal to Kh. That is also given Henry's constant, which is 76.48 into 10 ki power 3, because it's going to be kilobar into chi. And there you get the value of the mole fraction, which is going to be 1.29 10 to the power minus 5. These are the moles of N2 which are there, right? Moles of N2, rather mole fraction of N2 which is there. Now this is very less. Mole fraction is what? N2's mole fraction would be now chi A is moles of N2 upon moles of N2 plus 1 liter of water has 55.55 moles. Remember, your 1 liter of water has 55.55 moles. 55.55 moles. So it's N2 plus 55.55. But this value is very less, 10 ki power minus 5. Therefore, we neglect the denominator addition. And what we come up to is chi is equal to N2 upon N2 plus 55.555. Chi is equal to pressure of N2 divided by 55.5. Right, and there you get the weight of or the moles of your what? Your N2. Now calculate the millimoles of Henry's law constant. Right? Generally, people tend to think that your Henry has a difficult question to pose, but you see how simple this question could be. I'm just hiding it a little, hiding myself a little to be honest. Just see on how easy was this question. Your partial pressure was given, and your Henry's constant was also given in the same question. And in the same fashion, when you move, this was the fourth question that you have, comes the NCRT question 6 and 7. 2 minutes of time and try these two questions 6 and 7. Both are related to Graham's law, Henry's law, and therefore Henry's law is something where we have to figure out on how do we apply it quickly. 2.6 and 2.7. Same concept as we just finished in the paragraph above. Right? Right. Quick. Quick. 6 and 7. 2 minutes of time and do it. 2 minutes. Done. Sixth question. One of the two questions is done or not? One of the two questions is done or not? H2S is a toxic gas with rotten egg smell, is used for qualitative analysis. Thank you. If the solubility of H2S in water at STP is 0.195 molal, calculate the Henry's constant. Right, sir? Solubility is 195 molal, means 195 molal in 0.195 moles in 1 kg of water, which is my solvent. Right, 0.15 moles of this one H2S in 1 kg of solvent. Right, sir? Pressure is given at STP. It says STP is called as standard temperature and pressure. You can take it as 1 atm, or since the question talks about it's okay, you can take it as 1 itself, or say exact value 0.987 bar. 0.987 bar. So now what all do I have? I have multiple things here. Now my P is equal to KH into chi. P is equal to KH into chi. So my KH is P upon chi. P is KH is P upon chi. Right? P upon chi. Now where is P? What is P? P is my pressure. That is given as 0.987. And now what is chi? Chi is my moles upon total moles. What are my moles? It is 0.91595 divided by total moles, which is 0.195 plus of 1000 of water, which is 55.55. And that is where I get the total answer. I get the total answer, and the total answer is, let us calculate quickly. Let us quickly calculate, guys. Let us not stop ourselves doing it. It's gonna be 0.987 into 0.195 0.195 plus 55.5 divided by, you have 0.97 divided by 0.195. 0.195. 282 bar of the pressure. Very, very important key details there in the question itself. Number one, what were the key details? It was pressure. What was the concentration first? Molal. Then it was STP that talked about the pressure also. Correct, sir? Question number 6 also in text question done. Question number 7, Henry's law constant is given. It is given in terms of pascals. Remember guys, 1 bar is sort of 10 to the power 5 pascals. So we might have to use this conversion in the question. Calculate the quantity of CO2 in 500 ml of soda water when packed under 2.5 atm carbon dioxide pressure. Wow, pressure is given, KH is given, Henry's law constant, Henry's constant is given. Now it's the question of mole fraction. Very, very easy, but very, very important also. Very, very easy and very, very important also. Right? But same we have done it, so we will not take it up again, but this should be done into your end for sure. Question number 2.5 is Raoult's law with an extension in terms of Dalton's law of partial pressure that we will cover rather, but in class 11th syllabus. Dalton's law of partial pressure that comes from states of matter chapter. Quickly, vapor pressure of chloroform and dichloromethane are 200 and 415 mmHg. Pure pressures. So if it is A and it is B, so my PA naught is 200 mmHg and my PB naught is 415 mmHg. Right? PA naught, PB naught. Calculate the vapor pressure of the solution. How do we do it? So total pressure is PA naught chi A plus PB naught chi B. But for that solution, what do I need to calculate? Chi A and chi B. What is chi A? Sir, it's Na upon Na plus Nb. Sir, what is chi B? Sir, 1 minus Nb. 1 minus chi A. 1 minus chi A. Right? 1 minus chi A. Fine. Correct, sir? So now the first thing is how to calculate Na. Now I have been given 25.5 grams of CHCl3 plus 40 grams of CH2Cl2. Quickly, once I calculate the moles of it, it is 25.5 divided by 35.5 into 3 plus 13. 119.5 is its weight. And then you have 40 upon 71 plus 13, 84. 85. CH2, Cl2, it's CH2. So 14 plus 71, 85. So what are that moles coming up? Already mentioned in the text, but you should calculate on your own also. 40 upon 85 is 0.47, and then you have this as 0.213, right? So here I can get chi A and chi B. The first part of the question gets solved after putting these values. Any doubt here, you let me know. Any doubt here, you let me know. Very, very important. Very, very important, rather. Any doubt, you let me know. This is again, I should say, only the first part of the question, which is in the solution phase. I am still not talking about the question second part in the vapor phase, because in the vapor phase, the law that comes in is called as Dalton's law of partial pressure, right? And that talks about that your partial pressure, that talks about your total pressure is the sum of the individual partial pressures, and the partial pressure is proportional to the mole fraction. That is what the Dalton's law talks about, but we will come to this part in just 5 minutes from now. Okay, just 5 minutes and we'll come to this part. Not a problem. We proceed and then we move forward, 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 forward. Beautiful question. Same question as the solved example, with second part also as the same. Also find the composition in the vapor phase. Means which law? Dalton's law. NCRT for this chapter has been such beautifully defined, so beautifully defined, that any question that is in a solved example comes also as a part of this exercise in text, and same question you will find in the exercise also. Will get you marked of that question. Probably we will solve each of the exercise question in the second class, because all generally there are so many questions that you can never target them in one single class. It's very, very important, right? Good. The vapor pressure of pure liquid A and B are 450 and 700 respectively at 350 Kelvin. Find the composition if the total vapor pressure is 600. Very, very simple, sir. PA naught is 450. PA naught is 450. PB naught, right? Right, sir? PA naught is 450. And then PB naught, doing it with me quickly. PB naught is your 700, right? PB naught is 700. So where do we do it now? PB naught is 700. Where do we do it now? And then P total is PA naught chi A plus PB naught chi B. You get it as PB naught should be P. How do I do it? Put the value quickly. Its total pressure is 600, which is 450 PA, no, P chi A plus 700, 1 minus chi A. Remember, chi A plus chi B is equal to 1. Okay. Sorted, sir? Clear, sir? Done, sir? Done, sir. You get it as chi A and chi B. You get those values. Quickly, we can solve that here right away. 600 is 450 chi A plus 700 minus 700 chi A, which says that your 250 chi A is equal to 100. Chi A is gonna be 10 upon 25, 2 upon 5, 0.5. And therefore chi B is gonna be 0.6. But again, this is all in the solution phase. This is all in the solution phase. Why? Because, sir, my Raoult's law is applicable for solutions. Raoult's law is applicable for solutions. Done hai sir? Sorted hai sir? Very good sir. This is done. Correct? Solved question done. Good one. Right sir? Now, again vapor composition. We are still missing on that. We move forward, and then 2.6 question we get of the most twisting topic of your syllabus, which is called as relative lowering of vapor pressure. Right? Quickly, let us revise the formula. It was PA naught minus PA upon PA naught equals to chi B. For dilute solution, it is simply NB upon NA. Right? Even if we keep NB upon NA plus NB, it will be same only, but the calculation will increase a little. But even this will give you a fair enough close answer. Right? The vapor pressure of the pure benzene is 0.85. Absolutely fantastic, sir. Minus, okay. A non-volatile, non-electrolyte solid weighing 0.5 grams. When added to 39 gram of benzene, we will put it on the right side. A vapor pressure of the solution then decreased vapor pressure is 0.845 divided by 0.850 is equal to now mole fraction of the non-volatile component. What is the mole fraction? My moles, that is, it says weighing 0.5 gram upon x, the moles of it, and then your what is the moles of benzene? 39 upon 78, right? N2 upon N1. Simple. And that is how you quickly get the answer, because 39 upon 78 gives you 2, it gives you 1, it gives you 1, 2, 1, then you have 0.850 minus 0.850 minus 0.845, 0.005 divided by 0.850, you get 0.0059. This is the 1 divided by this one. What should I say? 0.00599. 1 divided by 0.00599. You get it as 167 166.9. I'm getting at 170. Exactly is what they have calculated. I think some mistake I would have done in the calculation, but 170 is the result that we are getting. Conceptually, we are exactly right. It is going to be 0.78 and then 2.5 into 2 is 1. So 1 divided by the answer is what you get the answer there. Right? 170 grams. Correct, sir. Very, very important concept. Not in terms of this question, I should say. Exercise has minimum 6-7 questions on this typical concept of relative lowering of vapor pressure. A very, very important peculiar concept where it can throw you a straight away question like this. And if you've done it first, it is always easier to get the answer taken out in just one go. Right? The second concept that we have is boiling point elevation. Formula that we have is delta TB is KB into M. Delta TB is KB into M. Then how do we say uh, 18 gram of glucose is dissolved in 1 kg water. Molality is straight away given, sir. Kb is given as 0.52, molality is moles, 18 upon weight, C672, O6 16, 6 are 96, plus 12. 72 plus 12 is 84, plus 96 is 180, into 1 kg is 1 kg, not a problem, sir. It gets solved in just single go. At what temperature will the water boil? 1.013 bar is your normal temperature, which is your water will boil at 373 Kelvin at your normal days. 100 degrees Celsius, right? This is 100 degrees Celsius, your water boils in normal, or you can even call it as 373.15 Kelvin, right? This also can be taken as your normal boiling point of water. Fine, normal boiling point of water. But then all of us know here that my delta TB is KB into M. So how do I do it? Delta TB is KB into M. How do I have to do it? It is now delta TB is KB, which is 0.52 into 18 upon 180, which is 10. यानी कि 0.052 is my delta TB, which means my new boiling point will be new BP will be 373.15 plus 0.052. Whatever is the answer that you get as 373.15 plus 0.052, it's 373.202 Kelvin, and you get this answer as, wow, 373.202 Kelvin. Remember, my delta TB is always change in the boiling point. Change, it remains the same irrespective of I am dealing in Celsius or I am dealing in Kelvin. The change will be same in both of them. Remember, 0 degrees Celsius is 273. 1 degree Celsius is 274. Change in Celsius is also 1, 0 to 1. And in Kelvin is also 1, 73 to 74. So what I am telling you that in terms of Celsius and Kelvin, your change remains the same. So when I'm talking about delta TB, it remains the same. Right, sir? Done? Good one. Then del 2.8 is again the same boiling point. The boiling point of benzene is 353, it is given. When 1.80 gram of a non-volatile solute was dissolved in 90 grams of benzene, boiling point is raised to 354.11. So what is the delta TB? 354.11 minus 353.23, 0.88. The first thing I have to take out is my delta TB, and that is how much? What should I say? 354.11 minus 353.23, that is 0.88 Kelvin. Again, I should say, since the both are in Kelvin, so I have taken in Kelvin, but the gap remains the same. Either we are in Kelvin or we are in Celsius. Very, very important. Right, sir? Great, sir. And then you get the value. KB is given to you, and then simply put the value and get it. Boiling point. Correct? Then the third concept. Oh, the screen is gone. Is it? Did I lose this connection? I don't want to stop the session. Yes, good one. So, I okay. Now we have the moving forward. We have the next concept. Hi Deepika, how are you? I am seeing you for the first time in this chat box. So I hope you are doing well. Although this emoticon doesn't suits me here, but thank you. Right? Good one. So now the next concept is freezing point. Delta TF is KF into M. And so we have question number 9 and 10 on the same philosophy, right? Quickly, let us do one ninth question. We can do that, right? Ninth question, we should do it right away. 45 grams of ethylene glycol is mixed with 600 grams of water. Calculate the freezing point depression. Calculate the freezing point depression. That is, we have to delta TF we have to calculate. And then the freezing point also means the new freezing point we have to calculate. Remember, your boiling point elevates, your freezing point descends, right? Boiling point elevates, my freezing point descends. Right, sir? Good one. Quickly. So now it says 45 grams of ethylene glycol, 600 grams of water. Delta TF is KF into M. KF is not mentioned here, but for water we should know the value of KF, which is 1.86. Delta TF is gonna be 1.86 into molality, which is 45 upon C2H6 ka weight should be 24 plus 6 plus 32, which is 62, into your mass is 600 grams in grams, so it is into 1000. Sir, how fast you are doing, sir. Array, but I'm telling you, this is how fast you have to process it. And this is very simple or not? Okay, molality is given weight upon molar weight. Given weight is 30, molar weight, okay, carbon is 12, 12, 12, hydrogen 1, oxygen 2, 32 and 16 or whatever. And then you get this answer, right? That is why question practice is very, very important. That is why question practice is very, very important. Quickly solve the answer. Quickly solve the answer. Right? So let us now do it quick. Done. Answers are done. Yes, sir. Answers are done, sir. Yes, sir. Okay. If answers are done, let us quickly solve it out. You have 600,000, 1.86. 1.86 into 45 into 1000 divided by 62 divided by 600 divided by nothing. 2.25 is the I am getting the answer. 2.25 is the delta TF. So now what will be the new freezing point? Sir, old FP is 273 Kelvin, or say 273.15. Makes sense, not a problem. 273.15 Kelvin. In the exam, it will be specified your normal boiling point, because if it is 273.15, we will take it as 273.15 only. We will not take it 273, and it has to decrease. So minus 2.25, and then you get the answer as 270. So my new freezing point will be, say, in terms of Celsius, minus 2.2 degrees Celsius. My new freezing point will be minus 2.2 degrees Celsius. Very, very important. And this is how you do it. Very important. Right? Same concept here in the next question. 1 gram of non-electrolyte solute dissolved in 50 grams of benzene lowered the freezing point by 0.4. 0.4 means my delta TF is given to you. Sorted, sir. The freezing point depression is 5.12 delta TF. Sorry, this is KF that is given to me. All I have to calculate and put the values is molality. All I have to do is this thing only, nothing else. So which is the formula? Delta TF is KF into M. Sorted. Sorted. Right, sir? Got it? Got it? Any concern in this question? Let me know. Any concern in this question? Let me know. Good. Next thing that I have is my question number 2.11 on the topic which is called as osmotic pressure, which is pi equals CRT. 200 ml, remember 1 centimeter cube is 1 ml. Always remember this. Always remember. Might you get confused in the exam, you have tendency to lose marks. 1 centimeter cube is 1 ml. 1 cm cube is 1 ml. 200 centimeter cube of an aqueous solution contains 1.26 gram of the protein. 200 ml contains 1.26 grams. Not a problem, sir. Why? Because the osmotic pressure is found to be 2.57 10 to the power minus 3. Pi is equal to C, concentration, weight, which is 1.26 upon molar weight. I don't know. Volume I know 200. Since it's in ml, it's in thousands. Right? Right? Pi is equal to C. R we all know 0.083. Gas constant. And then temperature is how much? 300 Kelvin. And you get the answer. It's just one single X that you have to calculate. Sir, I don't have good relation with my X. It's maths X. That is, it's a X which is there in maths, not your life. Sir, sir. No, sir. Please don't talk about X. No, sir. That is not what I'm talking about also. Okay. Quickly. We are done with this 11th question. Very simple also. And then we have 9, 10, 11, 12 in-text questions of these four colligative properties. Very, very important. I'm telling you, these in-text questions are always vital for the NEET preparation. Always. Always means you cannot escape these in-text questions. Never can you. Because after this, you just have two solved questions, 12 and 13, I should say, and then your chapter gets over. So when you have four in-text questions in one single go, you should not miss any of them. All four have different concept, right? We take one by one and then we discuss the vapor concept also that we missed it just above the that Raoult's law versus Dalton's law that we have to take up. Now, so vapor pressure of pure water is 23.8 mmHg. Pure water means say Pa naught. Okay, 23.8 mm. Not a problem, sir. 50 gram of urea is dissolved in 850 grams of water. Not a problem, sir. 50 gram of urea. They are giving me a hint of molality. Not a problem. Calculate the vapor pressure of the water. So basically, I have to the new vapor pressure. So what is the formula? So formula is very simple for me. It's Pa naught minus Pa upon Pa naught is equal to chi B. Right? Pa naught 23.8 minus x divided by 23.8. Chi b is Na upon Nb. Now we're making it Nb upon Na. We're making it very simple now. So sir, it's gonna be 50 upon 60, and then for water it's gonna be 850 upon 18. Right? And we get the answer. And we get the answer. Now this question, although 23.8 is a little difficult to calculate, I can say, but the same question with the changed numbers can be a question in your NEET 2024. In your NEET 2024. Very important. Very important rather. Right? Good one. So the boiling point, this is the first question that we have done. 10th question that we are now on. Boiling point of water is 99.63. Not a problem, sir. How much sucrose is to be added such that it boils at 100 degree? I want to elevate the boiling point by how much? Sir, 6.63 to 100 means delta TB should be 0.37. But again, you see, KB is not mentioned. KB, as I said, for water, KB and KF should be mesmerized. KF is 1.86 and KB is 0.52. For water, these KF and KB should be noted. It should be recorded in your mind because probably it might happen in case the NEET exam NTA misses it. You should know. You should not be missing this question only for the lack of this information. No. Right? So how do we do it, sir? Delta TB is KB into M. So how do we do it quickly? Delta TB is KB into M. Delta TB is KB, which is 0.52 into M. Now what is going to be M? How much sucrose is to be added? Sucrose is, what is the sir, what is sucrose, sir? We don't know. Please, sir, if you don't know, that is really bad out of you then. C12H22O11. Very important. Glucose, fructose, sucrose. Glucose, C6H12O6. Fructose, C6H12O6. Mixture of two, sucrose, C12H22O11. Very important. Right? But it was not even required because you don't want the molar mass of the solvent. How much sucrose is to be added? Yes. In 500 grams of water. Yes. So my answer is gonna be, sir, 0.37 is equal to 0.52 into how much sucrose is X upon its molar weight we have to calculate, and then 500 grams of water, it's in grams, so into 1000. Right? So C12, H22, C12 is 144, H22 is 22, O11 is 176. How do we do it then? 6 plus 4, 12, 10, 12, 1, 5, 7, 7, 7, 14, 1, 3, 4, 2 is the weight. 342 into 500 into 1000 is the value that I get. Now the only variable that I have to calculate is my X. 500 into 2, then 171 into 0.37, and then you get the answer. That is how this question number 2 can also be done. Question number 3, calculate the mass of ascorbic acid. Any such formula you need not mesmerize. It will be given in the question paper also. Ascorbic acid we need not know as well. To be dissolved in 75 grams of acid to lower its melting point. Now the question is, what is melting point? So melting point is where ice melts. For example, in terms of ice I am talking about. What is melting point? What is the melting point of ice? 0 degrees Celsius. So because above 0 it melts. And what is the freezing point of water? Freezing point of water is 0 degrees Celsius and melting point of ice is 0 degrees Celsius. Right? So remember, my dear bacha party, that melting point of solid, say melting point of ice, is the same as freezing point of water. Remember, this is very important and basic also, but the term should be very clear. Melting point of ice is solid, so it melts, whereas water is the liquid and so it freezes, but that happens at the same temperature. happens at the same temperature, right? It happens at 0 degree Celsius. And therefore, when I say that I have to decrease its melting point, so what do I actually mean? I'm talking about delta TF, and I'm giving you that value, sir. Melting point, sir, there is no condition like melting point. Sir, we have done only boiling point, freezing point, osmotic pressure, lowering in vapor pressure. Sir, no melting point, sir. Out of syllabus, sir. No, no. Out of syllabus, sir. अरे नहीं रे बाबा. It is melting point is same as your freezing point. It's just that the state changes, and therefore it is delta TF which is given to you already. Remember, questions language is the real game changer. Real game changer is the questions language. Right? Good one. The last question that you have, calculate the osmotic pressure. Simple pi is equal to CRT. What is all given to me? 1 gram of polymer in 1,85,000 is the molar mass. Done. I get the moles. Then volume I have, R I have, and temperature 37 means 310 Kelvin. Wow, all the required information is what I have. Pi equals CRT. And I have all the required inputs. So this is how I complete all the questions. Only just one concept remains. I'm going to that quickly. And that is how your entire NCRT in text and text questions can be solved. Yes, a little calculations involved, but that will make the base of attempting the question in your exam. That is very important, guys. I'm telling you, very important. Now, I take you to the question which we were on, Dalton's law versus Raoult's law. That is one concept which is still there. And what is that concept about? We are 2. Not this one, I should say. It was next to Henry's law. And we are here, right, sir? Chi A, chi B is what you get. Now, see what happens is, I'll quickly tell you, sir. 5 minutes, 10 minutes of more time, and it will be sorted. Sir, when I talk about Raoult's law per se, I have to, when I talk about Raoult's law per se, what I do is, total pressure is PA naught chi A and PB naught chi B, right? And this is actually the partial pressure. This is PA and this is PB. Sorted actually. This is sorted. Raoult's law. And as per Raoult's law, my partial pressure will be proportional to chi A. My partial pressure will be proportional to chi A. My partial pressure will be proportional to chi A. Right? And that is where this PA was PA not chi A. This was my Raoult's law. Now Dalton doesn't say that. As per Dalton's law, as per Dalton's law, as per Dalton's law of partial pressure, as per Dalton's law of partial pressure, my PA should be actually equal to P total into chi A. You getting my point? That my partial pressure of A will be chi A into total pressure. So when I go to vapor phase, the question talks about, sir, please say about vapor phase. So in my vapor phase, sir, my P, how will I calculate mole fraction? How will I calculate mole fraction? That's how my total pressure is given in the question. How much it has total pressure? 347.9 total pressure. So 347.9 into chi A. And what is PA? Sir, PA is what you calculated from Raoult's law. What was PA? Sir, PA was PA not Chi A. What was PA? I think it is say 285. If I'm not wrong, 285.5 something. So 285.5 divided by 347.9. 285.5 divided by 347.9, 0.82. And that is how you calculate the composition in the vapor phase. Remember, NEET has been asking this question, NTA has been asking this question. The vapor phase composition will be. And if you don't read the question well, you simply put Raoult's law and calculate and you mess up with it. Example in the next, okay, maybe you can note it down for a minute. Just the in-text question, what we were doing it. So in that question, you have been asked also find the composition in vapor phase. You just did it for the normal phase. Chi A was 0.4 and Chi B was 0.6. So quickly let us do it. The total pressure was 600. We will do that for vapor phase also. Total pressure was 600. Okay. Then my total 450 Chi A. What is Chi A actually now? Chi A and then P A is no, I'm so sorry. I'm so sorry. My total pressure. Wait. Sir, according to Raoul Dalton's law, your PA has to be P total into Chi A, right? So my PA is how much? I have to calculate 450 into Chi A, which is no. Okay, 450 Chi A, absolutely fine. So 450 into 0.4. So it is how much? 450 into 0.4 is equal to total pressure 600 into chi A. How much do I get it as? 450 into 0.4, 180 divided by 600, and chi A is what I get as 0.3. Now, this is the rule. This is the rule that you have to be very very careful while reading the question. Very careful. And by the simple concept of a hybrid mixture of Dalton's plus Raoult's law, NEET can put forward a question in the exam. And it has been doing it. Nothing new, to be honest. Once we solve previous year questions, you will get it. So there are questions that needs to be taken care. And they are important as well. Very important. Right? Done. It's really important is what I'm telling you. Okay? Taken, sir? Fantastically well. Now this covers all your solved in text, solved examples in text questions, which is very important. Almost 20-25 questions within the before the exercise kicks off. And when you go to the exercise, which also we will go in a session or so, is what you get that you have how many questions in total? 41 questions in the exercise, guys. So over 60 questions in the NCRT itself for solutions. Kindly gear up to practice these 41 questions on your own as well. Anyways, we will solve that in the classes also. Right? Please start preparing yourself for the NEET exam. Days are coming to be less in the time. The year will switch itself in the next 1 month. So please start preparing for the NEET 24. Even if that is not your goal, if NEET 25 is your goal, still take the value addition from these timings, and then so that the next year your preparation becomes very, I should say, very goal driven. Right? Take care. We'll see in the next class and solve more questions. Or rather, we are starting with organic series also. So we will say how we will solve the questions, but we have to and we will. Remember, watch this video minimum 2 times if you have any problem in the NCRT questions, and do give an attempt to the back exercise questions also. Right? See you in the next session. Bye bye.